Okay, yesterday we talked about long division of polynomials. We worked through them. You guys will have a couple long division on your test for sure. Yesterday we also talked about synthetic division, where you're going to synthetically divide and then whatever's left over, your resulting polynomial, is your answer if you would have divided using long division. Today we're going to talk about something called the remainder theorem. Yesterday our last example ended where there was no remainder. That meant that something was a factor. It worked out. When you are asked to use the remainder theorem, right, it's very important that you understand what the question is asking so you answer it correctly. When it says use the remainder theorem, I keep saying that, remainder theorem, what do you think is the only thing that really matters? The remainder. So when you solve something using the remainder theorem, what they're saying is, here's the number I want you to use to evaluate. Tell me what the remainder is. So if you look at these two questions, A and B, they're different questions. A says find the quotient and the remainder. A is saying, what is the answer to this question? So letter A, the way you would answer this is you would say, okay, this says 3x to the fifth plus 5x to the fourth minus 4x cubed plus 7x plus 3 divided by what? X plus 2. So what goes on the outside? X plus 2. Everything else goes on the inside, all right? What do we notice here? We have 3x to the fifth, yeah? Then we need an x to the fourth. So I have plus 5x to the fourth, yeah? All right, minus 4x cubed plus what? 0x squared. It's good. I don't have an x squared, so I have to account for it. Then I have plus 7x. Then I have plus 3. Right? This is a long problem, but that's okay. Find the quotient and the remainder says, I want the whole answer. So the first thing I'm going to do is say, okay, first term into first term. So do a little side work. X times what, guys, gives you 3x to the fifth. 3x to the fourth, right? So I'm going to put that above my x to the fourth. So I'm going to write right there. I'm going to get my subtraction ready before I go ahead and multiply. So 3x to the fourth times x is 3x to the fifth. 3x to the fourth times 2 is plus 6x to the fourth, right? And before I can subtract, what do I have to do? Distribute that negative. So change, change, change. So now this becomes 5x to the fourth minus 6x to the fourth, which is negative x to the fourth. What happens to my 3x to the fifths? They cancel. And then what happens here? We bring down minus 4x cubed. And we do the exact same thing again. First term into first term. So x times what is going to give me negative x to the fourth? Negative x cubed, right? So get your subtraction ready before you go ahead and multiply. Negative x cubed times x is negative x to the fourth. Negative x cubed times 2 is minus 2x cubed. And again, guys, before we subtract, what do we have to do? Distribute, distribute, distribute. So change everything. So you have negative 4x cubed plus 2x cubed. That's going to be negative 2x cubed, right? What happens to your x to the fourths? They cancel. And then what do I bring down? The 0 x squareds. You have to have a placeholder for what is missing. So again, first term into first term. X times what gives me negative 2x cubed. Perfect. Negative 2x squared. So get your subtraction ready before you go to multiply, I'm sorry. Negative 2x squared times x is negative 2x cubed. Negative 2x squared times 2 is minus 4x squared. Again, the same thing, guys. Before you can subtract, what do you need to do? Distribute, distribute, distribute. Good. So 0x squareds plus 4x squareds is 4x squared. What happens to your 2x cubes? They cancel. Awesome. And then what do we do with plus 7x? You bring it down. Plus 7x. All right. Again, this is a long problem, but that's okay. So now we're going to say first term again into first term. So x times what is going to give me 4x squared? 4x. Okay, good. So plus 4x. It's better if I write this like this so you guys can see it better. All right, so get your subtraction ready before you multiply. 4x times x is 4x squared. 4x times 2 is plus 8x. What do we do before we subtract? Distribute, distribute, distribute. So 7x minus 8x is negative x. What happens to your 4x squareds? They cancel. And then what do I do here with plus 3? Bring it down. So the last thing I have, first term into first term. X times what gives me negative x? Negative 1. Good. So negative 1 up here. Now, this is a super long problem. I understand that. You guys are doing a great job. Just stay organized. Get your subtraction ready before you multiply so you don't forget to distribute there. So now I'm going to say negative 1 times x is negative x. Negative 1 times 2 is minus 2. And again, what do? Distribute, distribute, distribute. So 3 plus 2 is 5. And my x's cancel out. So what is 5? It's your remainder. Is it a positive or a negative? Positive. So you would say plus 5 over what? X plus 2. All right, perfect. That is a super long problem. But the question asks, find the quotient and the remainder. That means divide. If it says to use long division, you do it that way. If it says to use synthetic division, you do synthetic division. But that's what that question is asking. When you divide, what is your full answer? Letter B is asking a different question. And this is where I want you guys to really pay attention because this is much easier. But if you're not paying attention to the directions, you'll answer incorrectly. It says use the remainder theorem. So when I tell you guys to use the remainder theorem, what is the only thing I care about? The remainder. And I will tell you what number to use to synthetically divide. I'm going to synthetically divide using negative 2. And all I want to know is the remainder. So when I do that, how do we do synthetic division? You write out what? The coefficients. So it's 3, then what? What's the coefficient of x to the 4th? 5. What's the coefficient of x cubed? What is it? Negative 4. What's the coefficient of x squared? There isn't one, 0. What's the coefficient of x? 7. And then what's your constant? What is it? 3? Okay, perfect. All right, so now when we synthetically divide, we bring down our first term, yeah? To 3. Now multiply to the corner. What's 3 times negative 2? Negative 6, good. What's 5 plus negative 6? Negative 1, okay. Multiply to the corner. Negative 1 times negative 2? 2. Add down. What's negative 4 plus 2? Negative 2. What's negative 2 times negative 2? 4. What's 0 plus 4? What's 4 times negative 2? Negative 8. What's 7 plus negative 8? Negative 1. What's negative 1 times negative 2? And what's 3 plus 2? 5. Wasn't that a lot quicker? Yeah. A lot better. Now, the question said, use the remainder theorem. So the way that you would answer this is you would say P or F, whatever letter they use, P of negative 2. When I synthetically divide with negative 2, what's the remainder? 5. That would be your answer for letter B. Now, if you were using synthetic division, if you used synthetic division for letter A, it said find the quotient and the remainder. Well, what are all of these things? Those are the coefficients, right? So this would be 3x to the 4th. It's always one less than what you start with. Minus x cubed. Minus 2x squared. I can't write. Plus 4x minus 1. And then you had plus 5 over x plus 2, which is what we got when we did long division.
For the remainder theorem questions, would there ever be like a question where there's no remainder?
Yeah, and it could be that. Good question. Say you work it out and there's no remainder. Say that happened here. You would say p of negative 2 and your remainder is 0. If there was none. Doesn't happen here, but if there is one. So just be mindful of what the question's asking. During the test is not when you're like, do you mean for us to do? That's your job to answer it. If it says find the quotient and the remainder, that means tell me what the answer is. If it says to use long division, use long division. If it says synthetic division, use synthetic division. But if it says use the remainder theorem, the only thing they care about is the remainder. That make sense? All right, let's look at the next one. The factor theorem. Okay, we talked a little bit about this yesterday. I don't know if you guys really caught on to it, but the factor theorem, what this means is when you divide and your remainder is 0. Then should be x minus c is a factor. Meaning whatever you divided by, x plus 2, x minus 3, is a factor. Just like if I said to you guys, is 4 a factor of 12? Well, does 4 go into 12? Yes. How many times? 3 times without going over, right? Your remainder here is 0. So yes, 4 is a factor of 12 because the remainder is a 0. So all this is saying is when you divide by x plus 2, x minus 3, 2x plus 7, whatever, and it goes in evenly with no remainder, then yes, something is a factor. That's what that means. So it says show that p of 1 equals 0. Use this factor. Use the fact to factor completely, okay? What this means, watch. They're telling me to use what? To synthetically divide using 1, yeah? So I'm going to put in 1. So my coefficients are 1, 0, negative 7, and 6, right? Bring down your 1. What is 1 times 1? 1. What's 0 plus 1? 1. What's 1 times 1? 1. What's negative 7 plus 1? Negative 6. What's negative 6 plus 1? Negative 6. What's negative 6 plus 6? 0. So is 1 a factor? Yes. Now it says to factor completely. That means factor everything as much as you can. Well, I have 1, 1, and negative 6 left over. What does that mean? What's my answer? X squared, right? Plus x minus 6 equals 0. To factor it completely, guys, can you factor that a little more? Yeah. You could use synthetic division again if you wanted to. But are there factors of negative 6 that multiply to give you negative 6 but add to give you 1? X what? X plus 3, x minus 2. So what are the other two factors of this? X equals negative 3 and x equals 2. Now, we could have told ourselves from the beginning that we had 3 answers because it was x to the third. We're going to do that a little more in the next section where you have to use synthetic division and factor completely and all that. So just bringing it to your attention. But let's look at these next two. Say the directions say use the remainder theorem. What does that mean? Use the remainder theorem. What do I care about? Just the remainder. So they're telling me to use negative 4 in my synthetic division. So let's write out our coefficients. We have 3, 4, negative 5, and 7. Am I missing anything? Are we missing anything? Okay. Everything's accounted for. So bring down that 3. What's 3 times negative 4? Negative 12. Okay. What's 4 plus negative 12? Negative 8. What's negative 8 times negative 4? 32. What is negative 5 plus 32? How much? 27, okay. What's 27 times negative 4? Write it out over here. 27 times 4. Excuse me. 108, okay, so it's negative, right? Negative 108. And then what's negative 108 plus 7? Negative 101. Now, the direction said use the remainder theorem. So how would you answer that if you were using the remainder theorem? Remainder theorem. P of negative 4 equals negative 101. Correct. Excuse me. If it said to divide and tell me the quotient and the remainder, what would your answer be? Hold on, quotient and remainder. 3x squared minus 8x plus 27, and then with your remainder, right? If they're telling, excuse me, if they're telling you to use negative 4, then this would be x plus 4 to put over. So it would be minus 101 over x plus 4. So just pay attention to what the directions say. If it says use the remainder theorem, then all they care about is the remainder. If it says to divide, tell me the quotient and the remainder, then you want that. All right, let's do this last one. All right, what am I using to synthetically divide? What number? 3. They told me to use 3 in the corner up here. So what are the coefficients? Oh, wait, sorry. Put a little square on this one. What are the coefficients? 2, negative 7, 5, and negative 6. Perfect, okay? So bring down the 2. What is 2 times 3? 6. And negative 7 plus 6 is? Negative 1. Perfect. So go to the corner. Negative 1 times 3 is? Negative 3. What's 5 and negative 3? 2. What's 2 times 3? 6. What's negative 6 and positive 6? 0. So using the remainder theorem, guys, how would you write your answer? P of 3 equals 0. Now, the fact that you got a remainder of 0, that means 3 is a what? Is a factor. If you wrote the rest of this, this would be 2x squared minus x plus 2, right? Equals 0. Does this factor more? Are there factors of 4 that'll multiply to give me 4 and add to give me negative 1? Right? So if you had to finish this problem to factor completely, what would you have to use? The quadratic. We're going to get to that in the next couple sections. When it says to factor completely, a lot of times you're going to use synthetic division for the first one. Then whatever you have left over, you can factor it either using grouping or trinomial. And if not, you have to use the quadratic formula. Yeah? Okay? All right, so